For thousands of years, humanity has looked into the night sky searching for answers. Every generation believed it had uncovered the greatest secrets of the universe, only to discover that reality was far more complex than anyone had imagined. Today, that journey has entered a remarkable new chapter. Nearly 1 million miles from Earth, the James Webb Space Telescope quietly orbits around the Sun near the second Lagrange point. Protected by its enormous golden sunshield and operating at temperatures colder than deep space itself, Webb is designed to detect the faint infrared light emitted by some of the oldest and most distant objects in existence. Unlike ordinary telescopes, Webb does not simply look farther into space. It looks farther back in time. Every beam of light collected by its mirrors has traveled across billions of years before finally reaching the telescope. Some of those photons began their journey before our own solar system even existed, carrying with them a record of the universe during its earliest moments. With every new observation, Webb continues to challenge ideas that astronomers once believed were firmly established. Recently, researchers analyzing one of Webb's deep field observations noticed something unusual. Instead of finding only the familiar arrangement of galaxies scattered throughout the cosmos, they observed an enormous region where matter appeared distributed in unexpected ways. At first glance, nothing seemed extraordinary. Deep field images often contain thousands of distant galaxies separated by immense cosmic distances. Empty regions between them are completely normal. Astronomers call these areas cosmic voids, enormous spaces containing far fewer galaxies than average. But this particular observation attracted attention because of the delicate structures surrounding one of these voids. Faint streams of ancient light appeared to outline enormous filaments stretching across unimaginable distances. These filaments were not entirely unexpected. For decades, scientists have known that galaxies are connected through what is called the cosmic web, a gigantic network of matter shaped by gravity over billions of years. Yet Webb's extraordinary sensitivity allowed astronomers to examine these structures with unprecedented detail. Instead of appearing smooth and uniform, portions of the cosmic web revealed intricate patterns that scientists are still working to understand. Some regions contained galaxies forming much earlier than predicted. Others appeared richer in heavy elements than existing models expected for such an early period in cosmic history. These discoveries do not overturn modern cosmology. But they suggest that the early universe may have evolved faster and more efficiently than previously believed. That possibility has become one of the most exciting areas of modern astronomy. Every observation forces researchers to ask the same question. Have our models underestimated how quickly the first stars and galaxies formed? To answer that question, scientists analyze the light arriving from these ancient objects. When Webb spreads incoming light into a spectrum, every chemical element leaves behind a unique fingerprint. Hydrogen, helium, carbon, oxygen, nitrogen. Each produces characteristic patterns that allow astronomers to determine what distant galaxies are made of without ever visiting them. Some of Webb's earliest observations revealed surprisingly mature galaxies existing only a few hundred million years after the Big Bang. These galaxies already contained large numbers of stars and unexpectedly complex chemical compositions. Such findings suggest that star formation may have accelerated rapidly during the universe's earliest epochs. If confirmed by future observations, astronomers may need to refine existing models describing how quickly galaxies assembled after the Big Bang. That is how science advances. Not by discarding established knowledge overnight, but by improving it whenever new evidence appears. The James Webb Space Telescope has already transformed our understanding of planetary systems as well. Beyond distant galaxies, Webb has studied the atmospheres of exoplanets orbiting other stars. By examining tiny changes in starlight as planets pass in front of their suns, the telescope can identify molecules floating high above alien worlds. Water vapor, carbon dioxide, methane, sulfur compounds. Each discovery brings scientists one step closer to understanding how planetary atmospheres evolve throughout the galaxy. Although none of these observations prove the existence of life, they demonstrate that complex chemistry is common throughout the universe. That realization alone has reshaped one of humanity's oldest questions. If the ingredients necessary for life appear across countless planetary systems, how many worlds might eventually become habitable? The answer remains unknown. But Webb continues collecting data with every passing day. Meanwhile, another mystery has quietly emerged. Some extremely distant galaxies appear surprisingly massive despite existing at a time when the universe itself was still remarkably young. Either these galaxies formed far more efficiently than expected, or scientists are still missing an important piece of the story. Neither possibility weakens modern cosmology. Instead, both offer exciting opportunities to deepen our understanding of how the universe evolved. Every unexpected observation becomes another clue. Every unanswered question inspires another investigation. And every new image reminds us that the universe is still capable of surprising even the most experienced astronomers. As Webb continues its silent mission beyond Earth, it gathers ancient light that has traveled across nearly the entire history of the cosmos. Within that light may lie discoveries that refine our understanding of gravity, reveal the earliest generations of stars, or explain how the first galaxies emerged from the darkness after the Big Bang. The greatest mystery may not be what Webb has already discovered. It may be what it has yet to find. As astronomers continued studying Webb's extraordinary observations, they realized that the true significance of the discovery extended far beyond a single image. Every new dataset collected by the telescope seemed to reveal another piece of an enormous cosmic puzzle. Instead of answering long-standing questions, many of Webb's observations created entirely new ones. The universe was proving to be far more dynamic, far more complex, and far more surprising than scientists had imagined only a few years ago. One of the greatest mysteries involves the earliest galaxies ever observed. According to traditional models, the first galaxies should have been relatively small, slowly growing as gravity pulled together clouds of gas over hundreds of millions of years. But Webb has detected several ancient galaxies that appear surprisingly bright and unexpectedly massive. Some contain billions of stars despite existing when the universe was still remarkably young. These observations do not overturn modern cosmology, but they suggest that galaxy formation may have progressed much faster than previous theories predicted. Astronomers are now refining computer simulations to understand how these enormous systems could have assembled so quickly after the Big Bang. Another mystery lies at the centers of these ancient galaxies. Webb has discovered evidence that some may already contain supermassive black holes only a few 100 million years after the universe began. These objects possess millions, and sometimes billions, of times the mass of our Sun. Exactly how such enormous black holes formed so rapidly remains one of astronomy's biggest unanswered questions. Some researchers believe they grew from unusually massive early stars. Others suggest that gigantic clouds of gas collapsed directly into black holes without first forming stars at all. Future observations may help determine which explanation is correct. Closer to home, Webb has transformed our understanding of star formation itself. Hidden inside enormous clouds of gas and dust are stellar nurseries where new suns are constantly being born. Visible light telescopes struggled to see inside these dense clouds, but Webb's infrared instruments penetrate the dust with remarkable clarity. The result is breathtaking. Towering pillars of gas, glowing shock waves, and newborn stars emerge from regions that once appeared almost completely dark. These observations reveal that star formation is an incredibly violent process. Radiation from young stars blasts away surrounding material while powerful stellar winds sculpt vast cavities across nearby space. Even in destruction, new creation begins. As old clouds collapse and disperse, fresh generations of stars begin forming nearby, continuing a cycle that has shaped galaxies for billions of years. Webb has also opened an entirely new chapter in the search for distant worlds. By analyzing the faint starlight passing through exoplanet atmospheres, scientists can identify molecules impossible to observe only a few years ago.